In the movie Lord of the Rings, one ring was created by Sauron so that it can rule all other rings. JavaScript is arguably the similar language. You can apply JavaScript on the front-end side, back-end side, database, your CLI, or any data pipeline. It is so versatile that you can write the entire tech stack only in JavaScript. In this video, I'm going to discuss important JavaScript language features which I typically use most often. So let's get started. All the code and examples I have used in this video, I have written it in the form of an article. You will find the link to the article in the description below. First, I will start with common JavaScript language features which are fairly easy, and then I will also discuss some advanced use cases of newer language features that has come in JavaScript. I recall when I started with JavaScript, lot of ECMAScript features were coming up since 2015, and those features really made the language more easy to work with. Over the years, those features have become integral part of any code base, but now the problem lies that there are so many features out there, it is difficult to even select which features to use, and hence it is difficult to find a right way to write a program. So there is no right way actually for writing a program, especially in JavaScript, but of course there are more shortcuts or the things that you can use, the language features that bring on the table so that your code base becomes concise and more readable. Let's start with string templates. String templates allows you to compose dynamic text. You can use variables in the values of text. So it is quite simple. Suppose I have object user. It has two properties, first name and the last name. Okay, and I have to compose a string which uses these variables. Then how we can do that? It is quite simple. We can create a variable, and in the variable we can add the text by concatenate this using plus operator. So for example, thank you, then the user dot first name plus a space user dot last name plus the last line. And if we log this message and if we try to run, so here you can see that it has printed thank you Janishar Ali for reading this article. Right, now you see there are a lot of verbosity and concatenation operation happening here. We can do the same thing using string templates. It is quite simple as well. Here in place of this message, let me comment this out. I can write a string template which starts with a backtick, okay, and then your text. After that, you can inject the values of a variable, for example, user dot first name using $, and within the parentheses you can supply the variable name. You can supply as many variable name as possible, and then you can supply the next variable which is user dot last name, and finally the text completion. Now this way you are just writing a single text and you are supplying the variables in between so that this text message becomes dynamic. Finally you console.log this message. Let me run this again. I'm using VS Code and I can execute this code using Node.js. So if I execute it again, you see it has written thank you variable value Janishar Ali for reading this article. So this way you can create dynamic variables. So there are many use cases of this string template and it is very convenient. You can also print multi-line text. For example, if I remove this here, so I have created a variable message and I have started my text with the backtick, and everything after the backtick will be taken as the string value. And here after this I press an enter and go to the next line. So I formatted the string as code, and finally I have closed this string with a backtick. When I again log this message, you can see that the output is in the format that we have supplied. Just imagine writing this same text in this format using string concatenation. It will be very difficult. String template is quite convenient in composing dynamic text as well as places where you want the formatting to be a part of the string. Now let's talk about a very important topic, which is how to declare a variable. Earlier in the JavaScript, we used to declare variables using var keyword. For example, if I write this way, var, the name of the variable, and the value as a string value. Now var does not restrict you from redeclaring the same variable. So I can redeclare var message and the world, and if I log this console, you will find that it is taking the last value. So this way I can declare and redeclare a variable and the program will execute. But this might not be desirable in an actual program. You might not want to redeclare a variable because this variable might have a value which is essential for the program. So in order to shield from this sort of use cases, now we have a better way of redeclaring it. Also, this var is function scope. So scope is very important in JavaScript. Scope is the visibility of a variable where the variable can be accessed. So var is not a block scope, it is function scoped. What does it mean? Let me show you. If I create a function fn, okay, function fn, and there is a loop, right? And in the loop we have created a variable I and we have declared it using var keyword. So for var I equals to 0, I less than 2 and I plus plus, and then there is a variable counter declared which takes the value I and then consoles on the log. Now after this for loop, I am trying to print this counter, although the counter was declared within the block of the for loop, but when I am trying to access it outside the block, I would be able to do it. Let me call this function again and execute this. Now you see the counter variable did print 0 and 1 in the loop, and after that it also have access to the counter. So counter lives beyond the scope of the block. So this is now scoped in the function. So whenever I declare a variable using var, it is scoped in the function. So it will be existing till this function exists, right? That is why it is not very good because the variable should be scoped within the block, which is more desirable in this case. Now in order to solve this problem, we have now a new keyword let, and using let we can do the same thing as we did with the var. But now let's see, if I'm trying to redeclare using the let, it says that redeclaration is not allowed. This is the lint checking in the VS Code. Even if I execute this, you see the compiler is throwing error saying that message has already been declared. So I cannot redeclare a variable. So that is the first safeguard and improvement over var. Now this is also block scoped. Let's take the earlier example and change our declaration from var to let. So this was our function, and in the for loop now I have let, right? And in the counter also we have changed from var to let. Now if I try to execute it again, let's see what happens. Now it says reference error, counter is not defined. So here on this line, where in the line 6, the line 6, if you see, we're trying to access counter, but it says the counter is not defined, so it is not accessible outside the scope of the for. So now the counter is in the scope, block scope, right? So this is another improvement where we can now scope a variable in the right context. So this is an improvement. One more very important use case is to declare a variable which cannot be changed after it has been created. For that we have the keyword const. For example, let's see this. So I have const message, for example, hello value. I'm trying to reassign the values in the message, which is possible in the let. Let's show you. Let, if I start with let and I declare a variable, I cannot redeclare a variable, but I can reassign it when I use let. If I execute this, you see the latest value of the message is world. But when I move the variable declaration to const, now if I try to do the same thing, now it says assignment to constant variable. So this message is now a constant variable and it cannot be reassigned. It is very important and I use a lot in my program whenever I want a variable which cannot be changed, and most often I don't want the values to be reassigned. I generally prefer immutability principle, where I create something and if any alteration has to be made, a new variable should be created. So a lot of use cases are there for the const. Now let's see a very interesting way of accessing the values of a array. If I declare an array, for example names, and my name, the two part Janishar Ali, and if I have to declare two variables which takes the values in the form that first variable should have value Janishar and the next variable should have value Ali, then there is a convenient way which is declaration of variable by destructuring an array, right? So here I write const and in the parenthesis I create two variables. One is Janishar, or I can call it first, and the second. I can call this variable anything that we desire, and I assign the array to that. When I do that, these two variables will map to the corresponding positions of the array, right? So if I console and log this, these variables first and the second, and if I execute this, you see I have the values Anishar Ali. So in this way we can create variable and assign the values from the array. So this is very convenient, and this is very useful in React applications. Typically in the React application you will see the code like this. You can create a state, and this is state returns an array of values, and here we can assign those values in two different variables. For example, expanded, this is the value that is created by this state, and the mutation of these variable can be done by set any variable name, set expanded in this case. So I am able to access the return, this use state return an array, and I'm able to assign it to the corresponding variables. Very useful and important for React use case. Same we can do in the objects as well. So object we can declare using parentheses, right? And here we declare a variable called user, and this object has three properties: first name, last name, and the address. Okay. Now I would want to create variables corresponding to each of these keys. As we did with the array, we can do the same with object destructuring as well. Here we can create constant, and for declaration here we write two variables and they correspond to the corresponding keys. So keys has to be matched, right? First name and the last name, and assigning the user to this variable declaration will assign the values first name to the key first name, the last name to the key of the object last name, right? And if I try to print this and execute this, you see I have Janishar Ali here, right? So this is also very useful in managing state in React.js. In React.js, you will find code like this. There is a state, auth state, right? Auth state had certain properties. For example, is logged in, user, all these keys are there in the auth object. We can destructure it into variables by using object destructuring like this, as we saw in the example. Now let's see how we can clone or create another object using spread operator. So first let's have an object called user, and it has three properties: first name, last name, and the address. What we can do, we can declare variable in this way. So I am declaring constant and it is going to destructure. So there is the first key which I want, first name, and I don't want other variables as an individual object, but rather I want a single object which has remaining properties. So first name will map to the first, and triple dot. Triple dot says that whatever properties remain after the first name should be assigned to a new object named rest, right? If I try to print this rest, let's see. So in the rest, you see we have two properties, last name and the address. So this way, by using the rest operator, we can filter out some of the properties from the object. Very useful. Now, one very interesting use case is to supply the variables in a function call. Let's again create our user object and let's create a function. So now this function fn takes two parameters, first name and the last name. We have provided it in the destructured format so that we can supply an object, and these two variables, if the key exists and in the past object, will be initialized. This function then prints the first name and the last name. Let's call this function and pass the user object. So we have supplied user object which has the corresponding keys which is required by the function, and hence when we pass the user, these two values from the user will be supplied to these parameters, right? Now let's execute this. You have Janishar Ali, first name and the last name, right? So this is also very important in the React. You will see this code everywhere. In the props, when you pass to any React component, you typically use this feature. So in React, for example, you can have an article page and it takes two props, article and the slug, and you can call this article page, pass it to any component, and here you can supply article or you can supply prop, right? So this way you can manage the props with the variable names that you would want to use in that particular component. Now default parameters in a function is another property which is useful. So not every time would want the caller to pass all the values. If there is configuration that is by default is true and you'd only want to allow user to customize it, you can use this property. For example, I create a function fn, the name, I have a default name and the roll number is the default 0 value. So in the function I am just logging the two variables values, and I can now call this function without passing any value, right? So this function will take the default values. I can also supply first name, which is my name, and if I execute this again, I'm getting the name which is the value passed, and the value which was not passed is taken as the default value. I can also pass the next value 100, and let's execute this, and you have my name and 100 here. So this way it becomes convenient where you don't want caller to always be supplying the values which might not be needed. Now sometimes you would want to have a lot of different values that could be passed to a function, but you don't want to capture all those values as a single variable, but rather you want to allow, customize that if one value or two value or multiple values can be passed. For example, I have a function and here the first parameter is type, and it can now take n number of parameters in the form of payload. So there are triple dot, you remember triple dot from the spread operator, same syntax is used but here in the variable argument, right? Now I would log the first parameter and then I will also log the second parameter. And how I can use this, I can supply the value to the parameter type, and in the payload I can supply multiple values. And if I execute this code, you will see that there is message, of course, the first parameter, and payload is an array. So whatever we supply after that goes into the array payload. I can supply more values, and I can log this. If I print this, you'll see all the values get into an array, and this array is now accessible in the function, right? Now let's talk about spread operators. Spread operators helps to copy all the array element from one array or create a new array with values from existing arrays. Okay, if we are writing immutable codes, especially in React state, this is very useful. So let's first create a variable called fruits. It has apple, mango, and orange, right? And let's create another variable called vegetables. It has potato and spinach. Now I can create one array and combine all the values of fruits and vegetables. Let's call it basket. So constant basket, and I am copying all the elements. This is again a spread. I'm spreading all the elements of the array fruit, and after that I am spreading all the element from the vegetables array. So this way basket will have all the elements from fruit and vegetables. So this is the way we can spread an array and create a new array. Let me console and log this basket and see the value. Now you see I have apple, mango, orange, potato, and spinach. Now similarly to this array, we can do it in the object, and it is very useful, especially in the state management in React application. Suppose I have a state object which has full screen and is logged in property, right? I want to create another state where I want to copy all the existing values and update some of the values of the state. Very useful in React application. What we can do here, we can create a new state, and here I am going to spread the state. When I spread the object, all the properties get inside the new state with the existing values. Now I can update the values which I want in the new state by mentioning the property name and the new value, right? If I log this new state, you will see that I am getting full screen is false, initial value, and is logged in is true, the updated value. Very useful feature in mutating states. I'll show you an example in React. Suppose I have a React component and I have a state which I call it default form state, which has the property email, password, and the error states of those two values, right? Now whenever I create a state, I'm going to supply the default form state. Now this use state provides us credential, the variable, and a function to update that state. We can have an event handler in the form. We will call it handle credential change, and this is a lambda which takes name, what is the name of the field, and then in the event that is provided by the form click in HTML. So here we can call this set credential and supply all the existing form state of the credential and update based on this name, right? So using this name in the parenthesis, we can say that whatever dynamically name of the field which I am going to provide in the function, that value will update from the event, right? Very useful feature in React. Now let's talk about arrow function. Arrow function is a new way of declaring functions. You can think it like that. For example, if we declare a normal function by function keyword, name of the function and the parameters, and finally the body of the function. I can call this function where I can supply the values to the parameters, right? If I execute this, you will see that I'm receiving these parameters. Now using arrow function, we can declare the function again, but here we are creating a variable called function, right? Fn is the name of the variable, and what I'm assigning is a arrow function. The arrow function is anonymous and it takes two parameters, and there is this arrow operator which says that it will execute this following body, right? So I am creating anonymous function and supplying it to a variable, right? Now you must ask, why do we have such an arrangement? It makes convenient to write callback functions, for example, or wherever you're passing a function to another function, then there it becomes convenient. Then you don't have to create a function separately, rather you can supply a lambda, right? For example, but before that, let's again execute this lambda to see it act as a normal function. Yes, it acts as a normal function. Now let's see a use case of this in the callback function. The callback function is a paradigm where we supply a receiver to a function, and the function, after doing some processing, return back the result. So for that, let's create a function, call it callback. It receives message and we're going to log that message, right? And if I create a normal function fn, it takes one parameter payload and a function callback, right? And the function we can call by passing an argument to the function. We can call this function by supplying this callback function, right? And if I execute this, you will see that I am receiving in the callback the message. The message is payment, payload is received. Payload is the payment and received. So this function callback receives the passed parameter payload and from within the function some value which was sent, right? Now here, whenever we have to call this fn function, we have to create another function, right? This might not be convenient. Hence, in the place of this callback function, what we can do, we can use the lambda function. In the lambda function, you can just remove this callback, not necessary. So we can call this function with the first parameter, which is payment, and signature of the callback, right? So this will be a lambda which takes message as the parameter and then executes the code. Let's execute this code. Now you see payment received is the output. So this makes our life easier, where we don't have to declare the function which is going to be passed. Also, one very nuanced effect is that it cannot be used before it is declared. So if I use declare a lambda function below, I cannot use it above or before its declaration, but for the function it is hoisted. It means that I can declare a function anywhere and use it even before the line of code where it was declared, right? Now let's see iterating over an array. How do we typically iterate over an array? Very simple, using for loop and the indexes. For example, I have a array fruit, apple, mango and orange are three values in the fruits, and here I can write a for loop, declare a variable to iterate, and it will go to the length, and each times it goes through the loop, it is going to print the corresponding values. If I execute this, I'm getting all the names printed one by one. But here we have to write this syntax where we have to know the length of the array, and we have to iterate by incrementing the iterator. There is a simpler version where you can use off keyword. For example, this for, now I'm declaring a variable called fruit, and off means it will go one by one into the array, and each time it goes into the array, it will pick that element and will supply into the loop. It will automatically stop when end of the loop has been reached. Let me execute this. the same result, right? Now it becomes much more convenient to write iteration over an array. Now some important array function which is very commonly used. Let's first declare one array. It has two objects. So the name of the array is items. It has two objects which has two properties, id and name, right? Now if we have to do certain processing for each element, for example, we just want the name, we don't want the id in another array, so then we can use the map. Map is like mapping one's values to the next value, right? So for that I'm going to create another variable called names, and here in the items, the array, I'm going to call a map function that lies within the array, and it takes one callback, right? So now in the place of callback I'm going to use lambda that we have seen just now, and here I'm going to receive in the lambda item, each element I'm going to receive one by one. So item I'm going to receive, and when I return something in the lambda, if I don't have parentheses, whatever I'm going to write is going to be the return statement. So I'm going to return item dot name. Okay, so whenever the map is called on this array, it will receive the first item, which is the object, and then it will going to return the name property. Whatever we are going to return from here is going to be the element of the names array, right? And it will run through all the items in the array. If I execute this, before that I have to log it and then execute. I have an array which has 1 and 2 elements, right? So here I can also return another object, for example, which has property index and the value. In the iteration map, I can receive an item, and alongside I can also receive its position called index. I am going to receive the value as an index. So whenever I am iterating over the map, I'll get the element and the position, right, which I can leverage to return an object and the property name. For example, the name will be in the item dot name, and finally if I log it, let me stringify so that I get the printable names. Here I have two objects, it says index 0 name 1, index 1 name 2. So this way I can return any type of object which maps to each element of the items, right? Now one interesting fact, it is going to receive the object. I can only receive the name here as well. For that I'll have to use the object destructuring which we have seen, and here we just going to receive the name, id and name, right? And here in place of item I can use the name. I'm not going to use id, I can just not use any name by underscore as well. See the same result, right? So many ways to write the same program. That is why JavaScript becomes tricky at times, because there is no right answer. But again, this depends on the team you are working with and your own way of writing JavaScript program. Now, as there is map, we have another function associated with arrays called find, right? So we can search an array and find an item. For that we have, let's suppose we want to find the item with id 1. So here let's create a variable called found, and in the items I'm going to call the find function, and it takes item, and here is the comparison. So I'm going to iterate over this array, and wherever there is item.id equals to 1, whichever item it maps, it will return the object as the found, right? And if it does not match any of the items with the condition, it is going to return undefined. Now let's log this found. Now you see I have found ID is 1, name is 1, right? Now let's say that I'm going to find an item with ID 3. So we won't be able to find it, and hence it will be undefined. Now found is undefined, right? Now similar to find, now let's see filter. Filter is to select items which matches some condition. Find is going to give you one item, and filter is going to give you multiple items which matches the condition, right? In place of this find, if I write filter and I want all the IDs less than 3, so there are 3 IDs, so I must get this array with the 2 items, right? And here if I execute this, so there are 2 items. Again, let me stringify. Now I have both the items. Now let's suppose I say that give me all the items with ID is less than 2, then I'm getting only one item. So using filter, I can filter items of an array based on the condition. Now generator function. Generator function is a very interesting use case where you would want to get the output whenever you call for that output, and you don't want to manage the state by using variables. So this is built into the language. For example, I have a function, and to declare that it is a generator, you have to use asterisk after the function. Function asterisk. So this is a function generator. Name of the function is pagination. I'm going to supply an array from which it is going to generate and the total size that it needs to generate. Okay. So I'm going to iterate over the array and I'm going to yield. So this generator first generator declaration by the asterisk after the function, and then yield is a keyword which supplies the output whenever this pagination is called. Each time I'm going to call, I'm going to move my selection from this array. So if I first create a pagination, so I'm going to call paginate, right, and provide an array 1 to 7, and each time I want an array of size 3, call it pages. When I call pages.next, it is going to call yield, right, and it is going to return 3 elements from this array starting from 0. I is 0 initially on the first call, and it goes from 0 to size which is the value 3. So it is going to return 3 elements starting from the first element. So whenever I call next, this function returns 3 first elements, right, and I can use the return from this yield by using the values. So let's call this. So I have 1, 2, 3. Now next time I call next again, so this I was 0 once, and after its execution I becomes 1, and the state of I was maintained within the function. So we don't have to write anything here, so that I value has to be maintained as a state. This state management will be done by the generator function itself. That is why this is useful. When I call next, let's see what happens. So now I have 4, 5, 6. I can call it again 7, right? So by calling this next, I'm iterating over the pagination, and the state of the variables are maintained by the generator function. So this is very convenient when we want to uplift the state management to a generator function. With the newer JavaScript code, you would find that oops and inheritance have become an important part of JavaScript code, and hence we have to also understand it. Although there are two different worlds, one favors the oops and another favors the functional approach. React.js in earlier days was leveraging OOPs, and you have classes and other things which are part of OOPs for the components. But nowadays, React has migrated to more functional approach. There are certain other frameworks, for example, Nest.js for writing backend services. It leverages OOPs, right? So different framework can have different preference. My rule of thumb is that when there are a lot of objects getting created in JavaScript, choose the functional approach. When we have concrete structures out of the data, and when the creation of object will live longer, then use OOPs. For example, in React.js, the components are created very rapidly. Each render time it is created again. So you don't want the oops there. You want it to be as light as possible. So their functional approach makes more sense. But in Next.js, once you have created a service, it is going to live for the lifetime of the application. So there having an oops is more meaningful, right? So for the oops part of the JavaScript, you can declare an object template using class keyword. For example, let's create a class called animal, and it will have something called constructor. So class keyword name is animal, right? And there is constructor. Constructor is a special function, and it is called whenever this animal new object is created. And you can pass the values to the constructor, for example, name and sound here, and I can assign it to a property in the class using this variable. This refers to the animal instance. So we have two instance variables, name and sound, which is associated with this object, and I am assigning the values, initial values in the constructor. I can have functions in the classes. They are called member functions, right, or methods, and these methods can have access to the property of the object using the this keyword again. So this way you are sort of encapsulating all the properties and the functions which are required or methods required to alter those properties within a structure. So it becomes very convenient because all the properties and the variables for the animal lie in a class. You can create an object from the class using the new keyword. So I'm going to create a cat. It is a new animal, and I'm supplying these two properties in the constructor. And when I call cat.speak, right? So I'm calling the method of the cat, and when it happens, this log will be printed. Now it says cat meow, right? Now I can create another animal, let's say dog, and the name of the animal is dog and it barks, right? So here I can again call the method dog.speak, and if I comment this out and execute, dog barks, right? So I can create multiple animals and I can customize the property because I have created a class which is like a template for that animal. And let's talk about inheritance. Inheritance is sort of extending the class with newer properties. For example, you have the class animal as we declared earlier. This animal has a constructor and it has a method speak. Now I am going to create another class called cat, and it will have all the properties of the animal, and it is going to modify or add some more properties. For that there is extends keyword. Let me write it down. So there is another class cat which extends this animal class. Extends means it will have all the properties and the method of the animal, and this constructor is going to take another property called breed of the cat. And whenever you are extending a class, you must call its constructor as well. To call the constructor of the animal, you have another keyword called super. Super will call the constructor of the animal. And here I'm going to supply these two properties required for the animal. and I'm going to assign the property which is unique to the cat, that is this dot breed equals to breed, right? Now I can add another method called show breed, which will log the breed value of the cat. Now let's create a cat. So there's a const cat, a new cat, and the breed is Persian. Now I can call cat.speak, right? As well as I can call cat.showBreed. I can access the property of my parent and also my own property. Let me execute. Now when I speak, cat meow, and when in the show breed, it's Persian. Now in the classes, there is static properties which are associated with the class, not with the object. So whenever we create an object, a copy, a sort of individual items are created and associated with the object. So if I have cat and dog and it has two properties, let's say name, so name will be different for the cat and the dog, but sometimes we would want to have one property shared across all the object, and for that we have called static. Let's create a class animal again, and this animal has count, how many animals are going to be created. So this is a property which I want to have inside the class itself. So whenever there is new object creating out of the class, all will have access to the same property, right? So for that we have to write static. The constructor, I'm going to increment the count. To access the static property, I have to use the class name directly and the property name, right? And then individual properties, name and the sound, which is going to be associated with each object of the class, has to be assigned by using this keyword, right? And similarly to the variables which are static, we can create methods which are static by calling this stat method as static method. So I can call the static method directly using the class name as well, and it will have access to the static variables. Now let's create a cat, right? And let's call this population. Because it's static, I have to call by the class name. And if I execute this, you see population is 1. Let me create a dog, and again let's call population. So now the population is 2. So this variable is shared across cat and dog, and this function is also shared across all the object. So benefit of this static is to have some tracker or something which you want to be persistent across all the objects. Now let's talk about modules. Modules are a way to expose your code from one file to another, right? So you can use export and import keywords when you are using modules. Typically you write a JavaScript program across multiple files and you want to expose some property or object from one file into another, and for that you are going to use modules. You don't want to expose everything from one file to another. That may not be desirable because of the privacy concern or because of the functionality or the collision between multiple files, right? So this module is only accessible in Node.js when you define type module in the package.json, or in the HTML JavaScript you have to mention the type as module as well, right? So suppose I have a function code.js here and it is type module mentioned in the package.json. I can export an object, and this object will now be accessible to another module, and the other module has to import it like this, right? This module 1 was in the file module 1, right? And it is exporting a object. In order to get or receive this object from module 2, you have to write import module 1 from module 1 inside the file module 2, right? Very convenient of scoping or selectively exposing the properties of one file to another. Now there are certain utility classes JavaScript provides to make our life easier. One is set. Set is a way to have an array with unique elements, no duplicates. So to create a set, you will call new set, right? So a constant s is an object of type set, and this set exposes method called add. So suppose I add apple, s dot add apple, then mango, and then apple again. So in an array you will have duplicates, right? Apple, mango, and apple again. But in a set only the unique values are going to be stored. So this apple duplicate will be removed. Let me log this. Now see, size is only 2, apple and mango. So the last addition was not captured in the set, right? Now similar to set, we have a utility called map. So I can create a map similar to set called const m is the new map, right? And in the map, just like addition of element, it has a method called set, which is a key value entry. So in the map, I can call m.set. The key is key and the value is going to be value 1. I'm going to add more key and values. So this map will have 2 keys and each key will be associated with 2 values. And I can log this key, and here key 1 is having a value 1, right? So I can access the value from a key by calling m.get and passing in the key name. This way I can have a key value pair inside the JavaScript. Now certain new properties are there which make writing JavaScript program much safer. The first is optional chaining. Suppose we have a state which is an object, empty object, right? Now if I try to access the property of the state which does not exist, but we don't know. So by mistake we write state.out.token. If I try to execute it, there's an error, right? The property is undefined and I'm trying to access the property. So in order to safeguard such code and without writing if else, we can do it by saying that state.auth only access token when auth is defined, else return undefined here. So if I execute the code now, this is undefined. So I can safeguard my code against such errors when I use optional chaining, right? Next one is nullish coalescing, which is to say that only process when it is defined, else return a default value. So let's take the state example again, which has nothing there, and there is a token. I'm going to access the token which is going to be saved in the auth object in the state. This is nullish coalescing. So it says if it is defined and has value, then just return that, else if it is undefined, use this value, right? So now the code will become safer. If I again log this value, not present. So my code does not break, it has no error, and it can take the default value. See, I am not writing any if else, and it is a lifesaver, right? Now let's see the case where the value is defined, then what happens, right? This state has auth property, and auth is again an object which has token property. And now if I execute this code now, you see the access token is accessible. Okay. Now let's talk about promises. Promises are one single feature which has made JavaScript so very useful. JavaScript works with a single thread in an event loop. If you want to know more about event loop, I have created another video for it. You can go through that. I will link in the description. Now, promises is a way to execute asynchronous code in JavaScript. Let's see from the example. Suppose I have a function called fetch data and I am creating a promise. To create a promise, I am going to use the keyword new, right? I'm creating a new promise object here, and this object takes a function which has two callbacks called resolve and reject. Resolve and reject helps to maintain the state of a promise. A promise can either live in three states. First is the pending state, that is, it has not been executed, or fulfilled state when the resolve is called. It can be in the rejected state when the reject is called, right? We'll see what that means further. So this promise is created and returned from this function. Inside the promise, I am going to create set timeout, and after 3 seconds I am going to call resolve and pass in a property, right? Set timeout defers the execution. It puts the execution into the event loop. So when I call fetch data, this promise is returned, and when the promise is returned, it remains in the pending state, and after 3 seconds it resolves, hence it is moved into the fulfilled state, right? So if I have to execute this, I will call fetch data, the function. After calling fetch data, I am going to receive a promise, and I can receive the resolved state, the fulfilled state, by using the then chain. So dot then after this promise, whenever it resolves, give me the value in the then. So this is the thenable chain, and it receives in the callback, that is the data, the resolve, pass in the value which is received in the data, and I am going to log this data. Let me execute this. After 3 seconds, you see data is received, right? Similar to resolving, you can also reject it. So whenever you throw an error, a call, a reject, then there will be a problem, because then it will go into the rejected state. We can catch that error. We'll see how we can do that. Let's change the fetch data, and here in set timeout, rather than resolving, just reject it with an error. When you do the rejection, when the promise is executed, it goes into the rejected state, and you have to handle it manually, otherwise there will be a uncatch error. Let's see. After 3 seconds, it says it is unhandled promise rejection. So to handle this rejection, what you have to do, then is going to receive the fulfilled state. To receive the rejected state, you have to call the catch. In the catch, you are going to receive error, and then you can log this error. Right? If I execute this again, after 3 seconds, you will see this error is handled gracefully. So a promise can either resolve or reject, and you have to handle both the cases, right? Now there is interesting part. Suppose you want to run one code after all of the things which are executed by promise has been done. We have finally, right? Finally is executed irrespective of there is an error or not, right? So here we can write console.log done, and let's execute this. After 3-second error and done. So finally is the block which will be executed irrespective what happens within the promise. Now we are using then, catch and all these functions which is attached to a promise. They are modern approach of doing the same thing using async and await keyword, right? For example, let's create a utility function, call it wait. Whenever I call wait, I'm going to supply how many milliseconds I want to wait the execution. I'm returning the new promise which resolves after that milliseconds timeout. Now here I am returning a promise. Why? Because this is a utility function. I want to create a example where I can wait for certain period for the execution of my promise. Now let's create a function, and since this function is going to wait for certain milliseconds, we have to use async keyword. So async, the function is async function. Why? Because it is going to wait on a promise. Async function fetch data and it will await for 3 seconds by calling this wait function. When it call the wait function, it receives a promise, and this promise is resolved after the 3 second. So till the 3 second, I want the execution to suspend on this line inside this function. It should not return this while this is resolved. For that I have to write await. If I don't write await, this will be executed immediately, return statement, and after 3 seconds this wait will be triggered. So this async and await works together. Let me use this function await fetch data. When I am awaiting again, so I'm saying get the data from the fetch data. The fetch data is, since a async function, I want to receive the data immediately on this line. So here I'm going to wait till this promise resolves, and finally I'm going to print this data. It waits for 3 seconds and finally data is received. So now this becomes convenient way. We don't have to write here then to get the data. I'm using await here directly. If you compare it with the earlier form, we could have used the then, right? But since the new keyword await, we can directly get the data by using the await. Now what about error handling? So for error handling, we have to use try and catch block. So there is no dot catch, but we have to use try catch block. For example, in the fetch data, after this wait, if we throw an error, right? If I throw an error and then execute this, after 3 seconds, you get unhandled error, right? So for that, you have to shield the, or you have to put the code inside the try catch block. Now I'm going to try this await fetch data, and if there is an error, it is going to go into the catch block, or else it is going to print this data. Let me execute this again. There's an error, but it is printed gracefully now, right? So these were the important JavaScript language features which I typically use